Welcome back, guys. Today we're going to be doing unions, and I've just finished reviewing interfaces that I did yesterday, and then there were some stuff that I left out about like flattening an object and wara. So did that. So now I'm just gonna do enums. They're named constants, I know. Okay, we're just gonna read through and write some code if we will. So without wasting time, I'm just gonna get into it. So enums are a set of defined constants. The simplest form of enum is a numeric enum. Okay, this is directions. Okay, there's no equal sign there. Just checking the syntax. Let my direction should be of type. Oh, wait a minute. Okay. Then direction dot north, and then this will be 0. Okay, they start at 0 unless you specify where we want to start. If you do equals to 1, then they'll start from 1, I think. Okay, the killer feature of enum is that I've never understood the uses of enums. So I guess here today I'm going to understand enums. Okay, this assigned in enums, whatever they're called. Okay, I've never understand way I would want to use enums. Then I hear people like Prime always talking about enums, so I'm like, maybe they are important, but I'm just saying, okay, just get into it. The killer feature of enum is that in your code you can have nicely named identifiers like direction north, and under the hood you can have simple unique values like okay, so you can also explicitly set the values, and TypeScript will ensure that they are unique. Okay, so yeah, I see where they could be used now. I see, but I just maybe in the back of my mind I'm like, man, it could have been an object or something. Okay, I see. Okay, so TypeScript will just ensure that the values are unique. Bidirectional mapping. Numeric enums are bidirectional, which just means you can easily convert from the underlying value to the name and vice versa. Okay, so you can convert from the underlying value to the name and vice versa. Constant direction value. Okay, this number will be direction value south will be 2, and then direction string abide. Okay, direction. Okay, we see. Then our assignment, support AI is an internal system that calculates the severity of customer support requests so they can prioritize the most important requests first. Okay, create and export an enum named request severity. The enum member should be in order. Boom, they'll have 0, 1, 2, 3, and 3. Okay, 0, 1, 2, 3. Let TypeScript handle getting the unique values by default. Okay, complete the isCritical function. It should return true if the given support request severity is equal to the enum's critical value and for those. So what is okay? Request subtype this. Okay, I see. So we're exporting an enum called. Okay, let me just go to code and just do enums.ts, and then we are exporting an enum called what? Request severity. Okay, so don't touch code about that, and then we'll export enum. Is it request? I think request severity, which is these values separated by space. No, man, to have these, yeah. there a faster way I could have done this? Okay, yeah, okay, so they'll have values from 0 to be 0. So okay, this one is of type that, and then you want to take in the support request, and then check this if it's if I want to check if the request dot what severity is equal to let's just say request severity dot critical. Okay, and then we return true, and then else we just return false, I think. And then we're just gonna go ahead and console log some few stuff. And, okay, so the method is taking in something like this, taking in an object. I thought the object is like only 3 things. Let's just, oh, it's 4 things by ID. Okay, then this will return, this is the expected value. What is going on here? Yeah, this is the expected. Yo, let's say taking in 3 things, and then okay, let's just so fix it here. So this, yeah, and then we'll have that. Just go ahead and print. Should expect a false. Yep. Okay, we'll see. String enums. Okay, we can have string enums. Numeric enums can be nice when you actually want numbers. You really want to AK out every last bit of performance. Numbers use less memory than strings, but often string enums are easier to work with if you just want labels. Okay, log level, error 1 info debug. Okay, structured logs, be a message of type string, this of type that, of type enum. Okay, then console log and whatever, console log level and message, and then we pass in the message, and then the log level, okay, and then the error. This okay. When enums only exist within your code, numeric enums are totally fine. They start to get really hairy when you need to serialize them into JSON or store them in a database. There's nothing worse than debugging API responses and seeing this ID lane and then type what the heck is 7. Okay, like yeah, I see. Makes sense. So you don't want to say something like this. User type 7. What does user type 7 mean? Is this the age? What is going on here? You want maybe like a nice value, like, okay, see where you would want string unions. Assignment. It's hard to tell the severity of a request record in the support database because it's just a number. Okay, let's convert them to a more readable strings. Okay, so we're going to convert this to strings. So it will be low, medium, whatever. I update the request severity in to strings value instead of the default number values. They should match the enum member names, but should be entirely in uppercase. Okay, yeah, we're using uppercase. Complete the convert severity function level function. Okay, you should take in an old severity number and return the corresponding request severity string value. Okay, if the given severity does not match any labels, you should throw a new error with the message unknown severity. Okay, let's see. When an enum is not given a value, it starts at 0 and auto increments from there. Yeah, but here they're going to be named, right? That was a terrible tip. So we have string enums.ts. That, I guess these are gonna be named, right? And this will be medium, yes, and then this will be high, and this will be critical. Okay, okay, so this is taken in like the old number, and then it returns the value. So like, okay, let's see, if number is 0, we return low. This, nah, man, what's going on there? Okay. Okay, so I'm gonna use a bunch of if statements. Oh, there's another way, because like there's no way it starts at 0. Yeah. Okay, so like if okay, severity request. Okay, this will be passed. This object will be passed a string. So we're getting the number. What? Wait. What are we doing here? Complete function. It should take an old severity number as value and return the corresponding request severity string value. Yeah, if given the severity number doesn't match one of the labels, it should throw a new error. Okay, so if number equals to 0, I mean, I don't want to do if statements. Okay, so if it's it is 0, then we'll have to return relax. We'll have to return then request dot low, and then if where's Copilot? This is where we use the Copilot to write this thing fast. Then we'll do dot medium. Okay, so then if I could have done else if, but I've noticed they do it like this. They were doing it like this. They're using if statement in these courses. So where am I to use else? Okay, I was supposed to use medium there. Okay, then I, and then if is equal to 3, then that'd be critical. We'll return dot critical. Else, no, we just, yeah, if we didn't return, we then come and just return new error, whatever, wrong. Wait, how did we get assignment? Wait, yeah, they will do wrong, I guess. Then we're just gonna convert whatever. Then let's just go ahead and pass in any number. Don't even need a testament. Okay, 0, yeah, obviously it will print low. Let's just go see the tests. 0, of course, below what? Okay, but the function is no longer taken in an object, it's taken in a single number. Expected 3 will be critical, 2 will be I, 5 should throw true. What is the function new error with the this unknown severity? Yes, saying when severity is 5 we throw true. Okay, let's just, like, I don't know, like if this is like the way to return an error. Let's just pass in that. Yeah, we threw an error and then it's returned it returned our error here. Yeah, this is fine. Enum compilation. Okay, enum compilation. Unlike most TypeScript features, enums generate additional JavaScript code at runtime. Let's see what happens when we compile this enum. We'll talk about how to compile manually later. Yeah, everybody knows how to compile. Just to tracy.function. Whatever. Oh no. No, I know how to compile. Okay, I know how to compile. Everybody knows how to compile. Okay, we do TSC first, I think, and then node after. Oh, we do TSC and then it just works. Okay, we get the Java. Okay, the compiled JavaScript is like unusable. Like you can't write in TypeScript and then compile to a JavaScript file and continue to maintain that code because it just looks, it looks like straight up magic. Oh, even if it's like strings, they still have the thingy. They still have the numbers. Okay, well, like if I used, was there like a way to like, there's no way. This generic code is a bidirectional mapping that we talked about before. From name to value, from value to name. Let's see, bidirectional. Okay, class rogue 0. Okay, this is 0 and this is row. Yeah, bidirectional mapping. Yeah, they showed us in the beginning. String enum compilation. Strings compile in a similar way, but then there won't be any numbers. Okay, strings do not support reverse mapping. They compile JavaScript only map from name to string value, not the other way around. You can use number. Okay. Support here uses custom numeric error codes to track different kind of internal errors. These codes are logged across systems, but for debugging, we want to display more information about the error. Create and export a new function called getErrorLevel. You should take in an error code number as input and return a string. Oh my god. Just confirming. If you take in an error code as input and return a string, you should use reverse mapping on the internal errors enum to get error name and return string in this format. And return a string in this format, code name, with code and name replaced by the actual error code. If given error code is not in the internal error enums, it should return the same format with the error name, but with the error name as okay. So it will be that unknown code colon unknown error. I see what we're doing here. Should I let me just program this again? No. Okay. Compilation. I have class in the morning, so I don't want to do much. If I'm being honest, let's just move it this side so we can do nope. What's this? And then we'll see our logs here. Yeah, this works. Yeah, we just do the thing, and then this will be this side, but it's there's no code. Yeah, we just come here for the code. Boot spellbook. Okay, yeah, this works. Yeah, so that I can type faster. So we need a function called get error label. What is that should take in an error code. An error code is a number and return a string. Okay. You should use reverse mapping on the internal. Okay, 101, 104, 114. You should use reverse mapping on the to get an error name and return string in this format. Okay, we're gonna end up returning a string in this format. Code colon. We're gonna end up returning a string in this format. Name. Wait till I get mom. Okay. And then name will be the I think we need that code for checking in whatever if it's there, and then because how would we know like that the error number is not here? So we would need the. Are we talking about severities? Yeah, we'll need the same code as this one. Yeah, like I don't wanna write this, man. It's too much. We can pass. So what we need to do, I could do like an if, and then when it's time for an error, just do the return the error. If like the code is there, we just put that code that was passed in the name, but the name, because we're using code, we just do it like this. We'll just pass in the number in like this to get the name. Like invalid whatever, this will be the name. Yeah. So I don't wanna write. Run. Okay, maybe I need to write error code. Nah, this is taking time, man. It's supposed to be a great way to do this. Okay, like my way is too long, so we're just gonna pass a const enums. I'll try it when I'm by myself, and I eat class tomorrow, so this thing is taking time. Const enums. There's a special variant of enums, const enums, which are completely removed during compilation, and replaced with their literal values. Unlike regular enums, they don't ship extra mapping code. Okay. They're completely removed. They are more performant, but do come with limitation. No computed values. They can reference other enum members, but can't use arbitrary expressions. Okay, const enums. Okay. Bird and the this is okay. It references. Okay, it is referencing things that are inside itself. This is not okay. const enum initializer must be constant. Okay, yeah, it can reference to other constants, so this will be okay. Yeah, this function can return multiple things, so no. Mapping issues, const enums don't have runtime representation, so getting the name from the number and isn't possible. So direction.west, okay, this will have an error. A const member can only be accessed using a string literal. Okay, and if you, it might return the value again. Alright, yeah, see, I'd only use const enum while I'm really concerned about performance and bundle sizes. I don't know. I see. Just enums. Okay, so these are limitations that you can't do bidirectional whatever, and they result in a small bundle size, whatever. What is the limitation of using const? In TypeScript, you can't reverse map from a value to a name at runtime. Yeah, this is the answer. You can't assign string values to its members. Shut up. You can't access its members view. They are slower than regular enums. No, they're faster. They result in a smaller bundle, right? It's gonna be a video. No. Nope. Enums versus unions. If you've been paying attention, you might be wondering, why would you ever do this when you could do this? My question also. Props of unions. Unions are what you use for complex types, so it feels consistent to use them for primitives as well. So unions don't add any additional runtime code. It's less verbose to write a union. Yeah. Pros of union. If enums. Okay, I'm kind of tired, man. Ish. Still have to do maths after this to practice mathematical analysis and statistics here. It's a lot. Pros of enums. Enums are slightly easier to refactor because if you change the value of a label, it adds to. You don't have to change the string literal in every place you use it. Yeah. If you change the yeah. If you're using okay, I get them though. If you're using numerical enums, then the reverse mapping can be useful, I guess. Whatever. Cut suit ads provides more context than just hearts. That said, any good editor is going to say type cut suit on Ava, so it's not a huge win. Personally, I use unions over enums pretty much every time. That's what I'm gonna do. In fact, Anders Berg, the creator of TypeScript, he said that they might not even add enums to TypeScript if they were starting over. Why? Come on, you still need enums. Don't just come on. That's your personal opinion, bro. People need enums. Okay, give people enums. Assignment: we've decided to refactor some of the support AI's old API pricing code, convert the existing API to a union type named API tier, update the get rate limit for tier function to work with the new union type, and sorry to this guy Anders Hillsberg for doing brr on his name. Okay, function to work with the new union type. Okay, so what are we doing? Convert the existing to a union named API tier to a union. Okay, we're converting the enum to a union to work with the new union type. Man, it works with enum, so I'm not gonna change anything. So that's that. So if you were to change it to an enum, to be an enum of this line, this, and then to be of type that. So switch tier. If tier, then we'll just change here and put the strings. If no, what will we do? If like it is equals to it's free, then we return 10. If it's basic, we just write the string basic and then write the string poor, write the string enterprise instead of doing API tier.enterprise. That's what I was gonna do if I were to code. No, we're not doing that. So I'll watch the video on my own just after I stop recording. So we did enums. I was like really interested at first, but then just lost all interest on enums. So like the sim hella cool. I will revise them tomorrow when I come back from class. So this will be to the end of today's video. Thank you for watching, and I will see you on the next one.